Good morning, Math 111 students. Here's a suggested timeline for you to finish. You can pause this screen and look at the projected due dates. Your homework assignments technically are not due until the night before, so 5/7 at 11:59 p.m. Okay, some of you guys have had questions about problems like page 5 of your notes. So here's brief description of page 5, especially here at the bottom. We're talking about confidence levels now, and with a confidence level of 90%, that means 90% of the area will live in this zone. Okay, we want 90% of our data to live within that number of standard deviations away from the mean. We don't know what that number of standard deviations away from the mean is. So we are looking for this z-value that's also called the critical value for this set of data. 90%, 95%, 99% are some super popular ones. If the data is normally distributed, we are looking for those specific confidence levels. So if 90% of the area is on either side of this mean right here, what's left over for that little section and that little section? 10% of the area. That 10% of the area needs to be equally distributed. So we're going to put 5% of the area over here and 5% of the area over here. Remember, when we're looking for z-values, we're going to have to use the body of our z-table. The z-tables are always supplied for you. It'll either say distribution table page 1 that has all the negative z-values, and distribution page 2, which has all the positive z-values. We want to look up the confidence level. We want to find this z-value right here. Our chart is limited to just showing us area to the left. So we've got 95% of the area to the left of this z-value. So I need to look up 0.9500 in my table. You'll be able to click a button to look at this. We know our z-value is going to be positive, so it's going to be on page 2, and we're looking for 0.95. In the body of this sucker, we're looking for 0.95. I don't know if you can see this or not, but there's 0.9505, and there's 0.9495. Our z-value is smack dab in the middle of this, right there. So we reverse look up, and the z-value is 1.65 or 1.64. And that is why the author of these notes converted it to 1.645, halfway in the middle. Here's how you can find z-values with your calculator. First, you got to turn your calculator on. We want the stats and distribution menu, so shift data, go over to the distribution list. We want to find the z-value, so that's the inverse normal. When we click that button, we're prompted for 3 different things. On the notes that are completed, that used the TI-84, and it's only prompted for one thing. But the area to the left is 95%. The average, this is the key, the average is 0. And the sigma value, or the standard deviation, is 1. When we calculate that, that's equivalent of reverse looking up 0.95 in our body of our table. And there it is. Let's do the other one real quick. Let's do 95%. So on this particular one, we want 95% of the area to surround that average, to surround that mu value of 0. We want to find these z-values, these critical values. How do we find that? Well, if 95% of the area is wrapped around this average, what's left to be evenly distributed here and here? That's right, 5%. Half of 5% gets placed over here. Half of 5% gets placed over here. And now what we want to do is we want to find the area to the left of this z value. The area to the left of that is comprised of 97.5%. So we need to reverse lookup 0.9750. We can do that on page 2, 0.9570, or we can use our calculator. 9750. So we want to do this computation with our calculator again. This time, 0.9750. The average is still 0, the sigma is still 1, and we want to calculate that. That's where the author of these notes gets this value right here. And that's how you find your so-called critical values. I hope this has been helpful. Shoot me an email if you have any other questions. I'll be posting more and more videos for our notes for you guys to watch and listen. Talk to you soon. Bye.